Let's take a look at graphing lines, and you're gonna have to graph a line given like a variety of things. So you should be able to graph a line that, let's say the line is y equals 3x minus 6. Okay, we know all lines are written in the form or can be written in the form y equals mx plus b. So in this scenario, we know the slope is 3 and the y-intercept is 0, negative 6. So let's go down there and plot some of this. So there is 0, negative 6. And then with the slope, we can just get as many more points as we want, right? A slope of 3. Remember, slope is rise over run. So a slope of 3 says if you go 1 over, you go 3 up, and we get another point. 1 over and 3 up, we get another point. 1 over and 3 up, and we get another point. All of a sudden, we can graph the line. Okay, so if I give you the equation in y equals mx plus b, we can graph it. Again, we can get more points because I can start with the y-intercept, and then using the slope, I can just get an infinite number of more points. And I wouldn't have had to go 3, right? I can go anything that's got a ratio of 3 to 1. Over 1 up 3, I could have went over 2 up 6, over 3 up 9, over 10 up 30, or even I could have went over a half up 1.5. Anything that has that ratio, over 1/10 up 3/10. Anything that has that ratio 3 to 1. And if you go the other direction, see how I went positive 1, positive 3, but I also could have went left 1, meaning negative 1, and then negative 3, because negative 3 over negative 1 is still positive 3. So a positive slope goes right and up, or it goes left and down. And again, if you include that, right, boom, and then there, and then we could have included that in that line. Okay, what if I'm graphing an equation and it's actually not in this form? What if it looks something like 2y plus 8x equals, I don't know, 10. Okay, well then go ahead and put it into y equals mx plus b. So let's move over the 8x, so negative 8x plus 10, and then let's divide by 2. When I divide by 2, I'm going to divide everything by 2. So let's divide the negative 8 by 2 and get negative 4, and divide the 10 by 2 and get plus 5, and then I can go ahead and graph it. Because once I have it into y equals mx plus b, then I can just plot the y-intercept of 5, and then I have the slope of negative 4. So 1, 2, 3, 4, down, 1 over, 4 down, 1 over, 4 down, 1 over, and then go ahead and graph it. Right, and I know that this has to have a slope of negative 4, and it had a y-intercept of 0, 5. Okay, again, you should be able to graph an equation of a line given y equals mx plus b, or you should be able to graph it if I gave it to you in this form. Let's go over two specials, right? The two special versions are horizontal and vertical lines. So what about if x equals 3, and that was the equation of the line? Well, if x equals to 3, that means every point has to have an x value of 3. Well, that's easy. That's just this line right there. Look at that. Every single point on that vertical line, that's a vertical line, has an x value of 3. It does have a slope, just as a reminder. This would have an infinite slope or an undefined. And then what about the other special version of like a horizontal line? So what if like I said y equals negative 5? So I'd come down here to all the points where y is negative 5, and I would draw a line. That line includes all of the points, that point, that point, that point. All of those points have a negative 5. So that's how you graph a horizontal line. That's what the equation looks like. And then that slope, as a reminder, is equal to 0. There's no rise for horizontal lines. So horizontal lines, vertical lines, and then their equations should make sense, right? Vertical lines have only x values, or they have the same x value, and the horizontal lines have the same y value. There's kind of your standard. There's something different. You could graph given, I could just give you 2 points. Of course, you could plot it. I could give you the intercepts and you could plot it. What if I just told you a point, 2, 3, and I told you a slope of negative 3/4. Could you graph that line? Well, sure, right? Just plot the point, 2, 3, and then just do what the slope says. Let's go over 3, 1, 2, 3, and then down 4. Okay? Over 3, 1, 2, 3, and down 4. Over 3, 1, 2, 3, down 4. There you go. There's your line. Again, you should be able to graph a line if I give you a point and a slope, because you can get all the other ones. Remember, this is going to go down 4, over 3. See how that's like a -4 down and the 3 over, so it's a negative slope, or it's a downhill slope. But it's the same thing as if I go left and up. Same thing. Right, left and up is the same thing as right and down. Right, they're opposite of each other, which is what a negative slope should mean. Right, a negative rate of change. Increasing one decreases the other. Increasing x, decreased y. Increasing y, decreased x, right? One's negative and one's positive depending on the direction you're going, right? Positive slope, negative slope, infinite slope or undefined slope, zero slope. So there's all these possibilities. But again, most of the time, you're gonna be graphing something when you have the equation. The easiest one is this guy. I could give you the x and y intercepts. That would be even easier. What if I told you the y-intercept was 0, 8, and the x-intercept was, -3, 0. Well, that's easy, right? So you would just plot that point, and you would plot that point, and then graphing it, of course, is easy. Then you're just connecting the points. So intercepts, that's easy, which is another way to look at it. So graphing from intercepts, graphing from 2 points, graphing from a slope, and a point, or a slope in the y-intercept, graphing from y equals mx plus b, and then graphing from like standard form. Again, if you have standard form, just go ahead and solve for y, and then again, once it's in y equals, then you know the slope is -4 and the y-intercept is 0, 5, and then go ahead and plot it. Okay? Hopefully this helps you get started and reminding you of what you learned in Algebra 1 about graphing lines.